All right, guys, only 4 problems to go over. So let's get started. Determining solutions from factored form. So all these today will have already been factored for you. So you don't get the expanded form or standard form of the polynomial equation. You get the factored form, okay? And so notice here we have y equals x squared times x minus 3 times x squared minus 6. Okay? Now remember, the solutions can be found, or the number of solutions can be found by looking at the degree of each expression. So here we have x squared, okay? So that tells us that there are at most 2 solutions there. This one says just x minus 3, so there's 1 solution there at most. And here we have x squared again, so there's at most 2 solutions there. Okay? So total we have 2, 3, 4, 5. So basically I count all the x's. Okay? So there's 2 here, 1 here, 2 there, that's 5. Now, to solve for the solutions here, you just simply set each of these equal to 0. Okay? Now, we've done this in the past. Whenever it's just x by itself and then to the power, we can just think of that as x squared minus 0. Okay? And so set that equal to 0. And so you add 0 here. And we get x squared equals 0. And then square root both sides. And you get x equals plus or minus 0, right? Because we always put plus or minus when we square root both sides. But notice here, positive 0 and negative 0 are really the same number. So although we have at most 2 solutions here, we really can only use 1 because 0 is the same number as 0. They're not 2 unique answers because they're the same thing. Okay, so we just say x equals 0. So really here, we only have 1 solution. Okay? At most, 2 solutions means that there are 2 different solutions, but since we have the same number here, 0 and 0 are the same number, or positive 0 and negative 0 are considered the same number, because 0 really has no sign, then we just consider that really 1 answer. Okay? Now x minus 3. X minus 3 equals 0. Now remember, this is linear. So whenever it's linear, linear meaning it's x to the first power. See, x to the second power means quadratic. Okay? And then anything to the third power means cubic. We're not doing any cubics right now, only quadratic or linear. Okay? So whenever it's linear, you just take the opposite of that number there. Or if you want to do it the algebraic way, you would just add 3 to both sides and you get x equals 3. You see? I could have just taken the opposite of negative 3 and gotten positive 3. So you can do that whenever it's linear. Okay? Now finally here, we have x squared minus 6 equals 0. Set it equal to 0, just like we did here with the x squared minus 0. Right? But this one already has minus 6, so that's why we use the minus 6. Add 6 to both sides. We get x squared equals 6 square root both sides. Here we get x equals plus or minus square root of 6. Now here we have 2 unique answers. One's a positive square root of 6 and one's a negative square root of 6. Okay? Those are 2 different numbers. It's kind of like saying 5 and negative 5. Right? One's positive, one's negative. It's not the same as here. Because remember, 0 is actually a non-positive number. It's a number right in between the positives and the negatives. Okay? 0 means nothing. Right? Like no value. But this is a value here. Square root of 6, if you were to enter that on the calculator, you'd get a number, a decimal number, right? So for example, the square root of 4 is 2. So that means the square root of 5 would be a little bit more than 2, and then the square root of 6 would be a little bit more than that also. So that's why we get that. Now, let me actually show you guys the square root of 6 here. So the square root of 6, the positive square root of 6 is 2.449, okay? But notice here, if I were to say positive 2.44 and negative 2.44, those are 2 unique answers, okay? So here at most, right, we have 2 solutions. So there's 1, 2, 3, 4. 4 solutions total out of this function here. Okay? Move on to the next one here. Now the next one here, they're all linear here. Notice x, there's one x there and one x there, okay? This here does not have an x. So that means no solution will come from there, okay? You only can get solutions from wherever there are x's, okay? So here we have an x inside this parentheses and another x inside this one. So they're both linear, so I can just go ahead and jump straight to the answers here. The solutions are -5, and for this one is going to be x equals +7, okay? And I'm done. Again, this one doesn't have an x, so I don't have to worry about it, okay? Oh, look at this one here, okay? We have x squared, and x squared. So 2, 4, 6 x's, right? And so let's go ahead and set this equal to 0. So it's going to be 3x squared equals 0. Just set it equal to 0 like that, okay? And then divide by 3. X squared equals, well, 0 divided by 3. If you do it on the calculator, you'll see it's just 0. 0 divided by 3 is still 0. Okay, so we get 0 there, square root both sides, and look, we're going to get the same situation that we did above. X equals ±0, but remember 0 is neither positive or negative, so we just say x equals 0. This one here, x squared minus 7 equals 0. Add 7 to both sides. X squared equals 7, square root both sides. X equals ± square root of 7. Okay? And we've already gone over how to simplify square roots, so you can look at the video for that or your old notes. Okay, now what about this one here? X squared plus 7 equals 0. So it's almost like this one, except that one had minus. So let's subtract 7. X squared equals -7. Okay? Square root both sides. X equals ±. Well, remember what we do when we have a negative inside the square root? We put an imaginary unit here. So it's I. And then we put square root of 7. Again, these are two separate answers, although they're both imaginary, right? They still count as two unique solutions here. So positive I radical 7 and negative I radical 7. Okay? These here, as opposed to this one that's imaginary, right? If you have imaginary friends, that means they're not real. So these are considered real solutions. So real, and imaginary. Okay? So we have 2 imaginaries and 3 real. 1, 2, and then this one counts as 1. Okay? So we have 3 real and 2 imaginary. Okay? Up here, I would just have only real. So 2 real. And over here I have 1, 2, 3, 4. 4 real. No imaginaries. Okay? You only get imaginaries when you have a negative inside the square root. Okay? Let's finish with this one here. So we have f of x. And by the way, f of x is the same as just saying y equals. Okay? So f of x equals x plus 5 squared times x squared plus 5 times x squared minus 5. Now, we have not done an example where the exponent is outside of the parentheses. Okay? But what does that mean, x plus 5 to the second power? Well, that means that we have 2 of these. X plus 5 times x plus 5. That's what that means. Okay? So really, it just means that we have 2. So x plus 5 squared is the same as saying x plus 5 times x plus 5. Okay? All right, now let's bring this down just so that we can have it all on the same line. Okay? And so here we're going to have 2 linears, right? Now notice here, both of these linears are identical. So we're going to say x equals 5 for that one. X equals 5 for this one. Remember, it should be x equals -5 and x equals -5 because you just take the opposite of that, right? For this one, let's set it equal to 0. X squared plus 5 equals 0. Subtract 5. X squared equals -5. Square root both sides. X equals, there we have a negative inside again, so that's going to be plus or minus imaginary radical 5. Okay, and then here x squared minus 5 equals 0. So add 5 to both sides. X squared equals 5. Square root both sides. X equals plus or minus radical 5. Okay? Notice I have to put plus or minus whenever I take the square root on both sides. Now let's go back over here to count the number of solutions. X equals negative 5 and x equals negative 5 are both the same number. Negative 5 and negative 5 are both the same number. So this one just really counts as 1. X equals negative 5. We'll have one real right there. Here I have two imaginaries. And here I have two real. Okay, so if it's not imaginary, then it means it's real. So I have 1, 2, 3 real and 2 imaginary. And that's it.